In this week's episode, we go down to San Diego to interview the co-founder and CEO of FormAlloy. Hi friends, welcome back to another episode of Making Things Fun, Cool, and Sexy. I'm your host, Christine Hollino, and today I am honored to have this beautiful, intelligent, and stylish powerhouse as my guest today. She's a fellow Women in 3D Printing Ambassador for the San Diego chapter. She sits on the board of directors of CMTC, and she is CEO and co-founder of a metal 3D printing company, FormAlloy, here in sunny San Diego. Please help me welcome Melanie Lang. Thanks so much for having me.
Thanks so much for coming. It's great to see you.
Yes, it's such an honor to have you on my show. You are just so amazing to me.
Well, thank you so much. I'm so happy that you could come down and show off a little bit about what we do.
Yeah, like you make some really cool parts. So how did you get into manufacturing?
So I'm an aerospace engineer by training, and I spent about 15 years in the aerospace and defense industry. And of course, I was always exposed to manufacturing because you can design amazing things and you can create wonderful things, but they have to be able to be manufactured and sustained. And that was really my first sort of view of manufacturing and the challenges I was facing is that you can make something sometimes, one time, or maybe make it in low quantity, but when you have to scale up and make a lot of them, and then you have a lot in operation, you have to be able to replace those parts or repair those parts efficiently. And that's a big challenge for the DoD. So was sort of my initial exposure to manufacturing and the importance of not just, like I said, making it one time, but the importance of being able to repeat that over time and then support those products. And then that's really how I got into additive as well.
Wow. So when you were going to school for aerospace engineering, did you ever think that you would be potentially making parts for the aerospace industry?
That's definitely not where I saw my career going. I thought I would stay more on the design side or sort of development. And it's been really interesting now seeing it sort of come full circle from early career and ideation and working on these huge projects that span, decades or sometimes longer, to being able to design and print a part, really in the matter of, weeks. So it's been really fun.
It's so incredible. And, I know that you just said additive manufacturing. Some people know that as 3D printing. And there's metal, there's plastic printing. Can you share what different types of metal 3D printing there are, and what does FormAlloy do?
Yeah, so there's several different types of metal 3D printing, and there's new technologies kind of coming online all the time. The primary technologies that have been used so far have been laser powder bed fusion, where you have a large bed of metallic powder and you're sort of using lasers to melt one layer at a time, and the part sort of emerges out of the powder as it melts one layer at a time. You have binder jetting, which is typically you are having metal powder with other sort of binders in that, and then at the end you sort of have to melt out those binders and are left with your metal part. And then we have what we do here, which is directed energy deposition. With directed energy deposition, you have some type of energy source and you have a feedstock, and you are building the part layer by layer. But unlike the powder bed situation, you are only applying the material where you need it. So in our case, we can use powder or wire for the feedstock, and we use laser for the energy source. So we're essentially depositing the powder or the wire exactly where we need it to build the part up layer by layer.
That is so awesome and cool. Technology is just so innovative, and every year it's something new, and this is incredible. I've been seeing a lot of DED more in the highlights on LinkedIn. Mm-hmm. Why the sudden buzz recently?
Well, I think some of the other technologies I mentioned, like powder bed and binder jetting, have been more widely adopted. They had more investment dollars, early on. They have more end-use applications and more sort of history. But DED has really emerged as, I think, a way to the future because of its ability to scale in terms of very large parts and also high throughput. So I think people have accomplished what they can accomplish with powder bed fusion, and I think it will still be around for a long time to come because there's a lot of benefits with that process. And same with binder jetting. The challenge with binder jetting is you don't get as good material properties typically and can't work with as wide range of materials. So DED has sort of emerged as this technology where you can use a very wide range of materials. You can scale it for high throughput, you can scale it for large size, and you can use it not only to build and manufacture new parts, but as we like to say, you can also enhance parts, repair parts, and join parts with this technology. So I think, as people have had supply chain challenges, this is a great opportunity to replace castings or forgings with DED because it's an affordable process. I think from a sustainability standpoint, you can use this process to repair not only the castings or the forgings themselves, but also potentially the tooling for those components. And then, now we're talking about how do you use different materials or multi-materials or even custom alloys to get a part that can perform better than its traditionally manufactured counterpart. So I think it's really just been thrust into the spotlight, and I think, we're ready for the challenge.
Yay. When you say multi-material, so I've seen parts that has like copper on the inside, maybe stainless steel on the exterior. Do you do something like that here?
Yeah, absolutely. That's one of our specialties at FormAlloy is we can deposit materials very precisely. We can do very large amounts of material very quickly, but we can also do very fine feature and be very precise with where we're depositing powder or wire. And with that comes the ability to be very specific about what materials you want in what locations. So we have applications for aerospace and for consumer goods where we have been able to deposit copper and Inconel or some other material with it, so that way you can really control the thermal properties of that component. And it's been really interesting, and I think that's a big part of what the future will look like is these multi-material components where you can design and manufacture them for performance rather than being limited by having to use a single material.
Yeah, like with machining, obviously you can't do that unless you braze different materials together. Mm-hmm. But this is so awesome that you can just print it in one piece, and it's how many different materials can you print?
We can work with a very high number of different materials in a single print. We have one feeder that has 16 different hoppers with it, so it's sort of a tool changer for materials. So even just with one of those, you could achieve 16 different alloys or custom materials in a single build. And of course, you could combine multiple of those together. I think the challenge with multi-materials is making sure that they are metallurgically viable to bond together and not form brittle intermetallics or some other undesired phase in the material. But I think that's also something that we're working on, where even if you need to have two different materials that don't bond well together in a single part, we can oftentimes do what's called functionally grading, where we're slowly transitioning from one material or another, oftentimes using a third material as sort of a butter layer or a buffer between those materials. So you can slowly transition from material A to material B. And oh, by the way, that transition doesn't have to just happen in the Z direction. So as you're building up layer by layer, you don't just have to change in the height. We can also do interlayer changes where you're changing back and forth from different materials in a single layer, or even doing patterns. So we just did a study where we were doing functionally graded materials in a diagonal type fashion. So we're changing it in the X and Y and the Z direction during the build. So it's pretty exciting if you think about how that's really going to open up the design space.
Yeah. That falls under the name of the show, making things fun, cool, and sexy.
Okay, thank you.
Totally. So what fun, cool, or sexy parts do you get to make here at FormAlloy?
So we get to make a lot of different things for different industries, from automotive and aerospace to consumer goods. And then we get to do some fun projects as well. So I was part of a BattleBots team a couple years ago, and we made some aluminum teeth. That was basically the grill for the robot. And so that was something that was really fun, and a great way to sort of do what your mission is, right? Is what we're doing is cool. Manufacturing is cool and fun and sexy, and we need to sort of inspire the next generation to get into it. So doing the BattleBots was really fun, and it was actually the teeth that are here on the shelf.
Oh,
this is
so cool.
High strength aluminum. So this is actually like an aerospace grade aluminum. And this was the grill on the robot, and at one point it got pretty beat up and pretty destroyed, as they like to do on that show. And one of the only things that survived was the grill.
Oh, that's so fun.
So that was neat. And then, really the multi-material stuff I think is super cool, because there's really no other way, and there has never been a way to have a part where you can have materials embedded into other materials and really have fine control over how that part performs. And as you move along the part, there could be different performance requirements for temperature or strength, and now we have a way to make that happen.
That is so incredible.
Thank you.
I can't wait to see where this opens up for the industry to be even more innovative.
Yeah, absolutely.
So while I was doing research on the podcast on you, so that I could figure out what else have you done for this industry, I saw that the America Makes, they asked you to be on their executive committee. Can you share the mission of America Makes?
Yeah, so America Makes is really about being able to manufacture and innovate, within the U.S. And so it's a way for organizations to share information and to really push the mission of additive manufacturing forward, in this country. And I would encourage, whether you're a small business or a large business, it's a great organization to join. There's great networking opportunities to meet with like-minded people who want to push manufacturing, and particularly additive manufacturing is America Makes particular mission. Just push that forward. Make sure that we have solid domestic supply chains, and be able to share information, because a lot of the projects that they do are of interest across a much wider group of people. So it's a great way to not have to sort of start from the beginning if you're getting into additive manufacturing or working with a new material. A lot of times there's data that can be shared that some of the partners have submitted or funded projects where all that information is shared amongst the members.
Awesome. So you're on the executive committee
I am, yeah. I'm one of the small business representatives on that committee.
That's so awesome.
It's been a big honor, and it's been a great way to network and raise awareness about additive manufacturing.
Yeah. So you're a mother, you're a wife, you're a CEO, co-founder, executive committee, board of directors, ambassador. You are doing it all. How are you able to juggle all of these things?
Well, I think it is a lot of things, and a lot of times it is a juggling game. So there's certain days that things don't come together all that well, and I think it's all about on any given day or a particular time frame, the priorities might change. And I go very much based on sort of my list of priorities. So there's certain times when I have to take a step back and I have to focus on my family, and then there's other times that I'm going to be on the road and I'm going to be focused on visiting with customers or that kind of thing. Certainly being a part of these committees is really important to sort of push the additive manufacturing industry forward and mature the technology. So that's one of the priorities that I have. But I don't always do it well, I guess is really the answer. Some days are challenging trying to get everything done and fit everything in. So I just think it's all about having good priorities, and then also just you have to have passion and really love what you do if you're going to maintain all these different organizations and and events and have a family. Like it really has to be partially a labor of love. So and FormAlloy certainly is that.
Yeah, I totally agree. You're such an inspiration, and I think other women, when they look at you, they're curious, how are you able to do it? So if you could give a piece of advice to other women if they wanted to start a business, what would that be?
I mean, I would say you just have to do it. It always takes a leap of faith. If you're going to try something new or start a new business or really get out of your comfort zone at all. But I think it's important that if you are going to grow and improve and do something different, it's going to be a little bit uncomfortable. It's never going to be the exact right time, right? Sometimes you just have to have a leap of faith and jump in. And you know, it's not easy, but it's certainly worth it. So I would say do it, make it happen. And it's not going to be perfect.
It's not. I mean, like I started this podcast and I'm like, I have no idea what I'm doing, but let me just give it a shot, right? Because we won't know unless we give it a try.
Absolutely.
Yeah, you're such an inspiration. It's such an honor to talk to you. And up next, we get to have a tour of her manufacturing floor. You'll get to see so many cool things here. And I always ask my guests this, since I'm really into self-development. I always think that people have to go through a lot of failures in order to be successful. And I think sometimes younger people, they think that we are just perfect and everything was kind of handed to us. Mm-hmm. But the actuality is we've been through failures in order to get to where we're at. Can you share some failures that has helped you become the successful person as you are today?
Yeah, I mean, I think I've had a lot of failures for sure, you know, both professionally and personally. And like you said, you learn from them and it makes you, you know, stronger and better. One of the things I can share, you know, about our mission here is that I had initially intended on, you know, raising a large sum of you know, probably VC money, as most other additive manufacturing companies sought out to do. And that didn't happen. And, you know, I think part of it was DED was not as widely as accepted as it is now. And so I think people were a little bit worried because it hasn't been used so much in end products. And this was several years ago. And so instead of, you know, going out and raising a big round, we decided to go more the grassroots round. We raised a very small round with a strategic investor that was also a customer of ours. And that has been just an outstanding relationship. We've helped them do amazing things, and their, you know, small amount of funding that we got several years ago helped us to scale our initial manufacturing facility. And since then, we basically are growing and continuing to invest based on revenue that we're generating from customers that are doing great things with our technology. So I think given where the additive industry is now, I think that was really a blessing in disguise, although it was disappointing, you know, several years ago when we wanted to go raise this big round and we wanted to grow really quickly. Looking at where things are, I think it was actually a pretty smart decision to scale back and say, we have a customer that's willing to fund us, but they didn't want to get involved with, you know, these big financial, you know, investments and that kind of thing, because they wanted it to be about the technology. And so we decided to go that route instead and sort of forego the large raise. And although that was a failure at the time, for me, I think it was actually the right decision. And I think, you know, we talked about this a little bit before we started filming, you know, slow and steady wins the race. Although we have significant growth every year, it's sustainable. We're not doubling the number of employees, you know, every month and, you know, getting into a situation where, you know, we're just growing out of control and then we're not focused on where we're spending money. Mm-hmm. And are the people happy and just all the things that, all the care and feeding that a business needs. And we've sort of been able to do that because of our, you know, sustainable growth. And I see us continuing on that for a long time to come in the future.
I think that's an amazing strategy for any business, right? Slow and steady, so that you're not growing too fast and exploding along the way.
Right.
So really awesome. And where do you see FormAlloy in 5 years?
Yeah, I see us, you know, much bigger than you are in the facilities that you'll see today. I see us delivering, you know, a lot more machines, because this technology will be used in a lot more end-use products in the future. Not only for casting and forging replacement, but for repair applications and for the enhancements like we talked about, where you can make these multi-material components that can perform much better than their traditional counterparts. And I think that you'll start seeing it in even consumer goods type applications, where there'll be things on the shelves that have DED technology embedded into how they're manufactured. Not necessarily the whole part, but potentially taking a forging or a casting that's relatively low cost and adding some high value material to make it perform, much better. So I see DED becoming a technology that is, much more recognizable and kind of everywhere you look.
Well, I'm excited to see this happen and flourish for you. Let's go on the tour and check out your manufacturing floor now.
Sounds great.
Yeah, thanks so much.
Thank you. Well, thanks for coming back and seeing our production facility. So back in this area is where we produce all of our machines. We have several different production cells, so we can make our smaller and our larger machines in the same area. And this machine was just recently commissioned and fired off. This is our X5. So it has up to 1 meter by 1 meter by 650 millimeter in Z build volume. So quite a substantial build volume. I mentioned this process is scalable, so this is sort of one example of that. You can go very large. And this machine in particular has a green laser. So our machines can run with IR lasers, blue lasers, and green lasers, depending on the material that you're working with, or sometimes customers have a particular laser that they want you to use. And you can also have multiple lasers on a machine to accommodate more of that variety. So this particular machine has a green laser on it, and we're doing some really cool projects on this machine. And you can see what our controller looks like. If you're familiar with machine tools, it has a very familiar look and feel to it, so you can pick it up very quickly. And these machines do run like a machine tool, so you can set them up and program them. You can walk away from them. They do run autonomously. And one of the things we are known for at FormAlloy is what we call our DED Smart or DED Smart capability. And that is all the in situ monitoring and control that's keeping the build consistent, and then collecting and analyzing that data to ensure you have a high quality part and it's very repeatable. And so yeah, that's what you're looking at.
And is this your largest printer, or this is the largest one?
So this is the largest one that we have on the floor. We can go larger. We can make custom machines that go larger than this and have further extension to the build volume. But this is our largest sort of standard size.
So what's the largest you have been able to make for a customer?
So we did a project that was about a 7 or 8 foot long part. It wasn't super tall in the Z direction, but it was very large in X and Y.
Oh, very cool.
So that was pretty cool.
Yeah. All right, well, let's go check out other tools now.
Okay.
And what do we have here?
Okay, so this is our smaller machine footprint. So this machine is about a 300 millimeter in X, Y, and Z build volume. Full 5 axis, just like the larger machine that you saw. And this machine is actually doing some builds for us right now. And what's really interesting is the project that we are doing, like I mentioned, how we can add high value material to an existing part. So we actually have some forgings that are made in very large volume for a consumer good application, and we are just adding material just to one small area of that forging to make the part perform much better than it would if it was just a forging. So this is something that would be, very difficult, if not impossible, to do with the material combination that we're using here, and something that will have great impact on the end user's experience with this part.
That's so awesome. Does it sit on a build plate?
Yes, yeah. So the part that we have is essentially fixtured to a build plate, and then we're building right onto that part, instead of usually you would build onto a build plate and then have to cut the part off. So we're doing more and more where we're trying to build onto an existing substrate to help reduce build time, and also to just sort of eliminate the waste and the time that's associated with having to start with the flat build plate and cut it off. Yeah. So we're starting with more, curved surfaces, or something that can be more integrated into the build itself.
So awesome.
Thank you. Okay, so this is an example of a multi-material component. This is a scaled down version of a rocket nozzle. So on the inside you have a copper alloy for thermal properties, and the outside material of that is Inconel, which is a nickel superalloy, which is high strength at high temperature. So perfect for an aerospace rocket type application. This part is really interesting because you're able to get complex geometry with the cooling channels and the multi-material. And the multi-material is happening within a layer. So you're actually changing material within a layer, not just changing as you build up in the Z direction.
Wow, this is so cool.
Not magnetic, not magnetic, and then you feel the pull down here. And it's slowly, you can actually, if you move this along, you can actually feel it getting less and less and magnetic as you go.
Can I try it?
Yeah.
And can you explain this?
Yeah, so this part, this is a rapid deposition part, so we were building it very quickly. And at the bottom is 17.4, which is magnetic. The top is 316, so it's non-magnetic. And it's slowly transitioned from the 316 to the 17.4. So you can see as you run that magnet across it that it's very strong magnetic down here, sort of in between in the middle, and then up here not at all. You can see it. You can kind of feel it. So that's a good way to demonstrate how you can slowly transition materials and how their properties can change.
It's awesome.
So this is an example of a multi-material part where it's really easy to see because you have more of a discrete transition there. So you have a copper alloy here, and then you have a nickel superalloy on the other side. This part we call splat. This was just a fun little piece that we made. This is also a discrete transition, and this is basically showing that you can have also a thin layer of a different material on top of your base material to achieve whatever you're trying to achieve, whether it be high hardness or wear or corrosion resistance.
Awesome.